Good morning, everyone. Am I audible? Okay. Why always so few students? Because that day when I was giving the total strength of the class, it was like 43 or 44. But in the online class, it is so less students joining the class. Like always, I have seen maximum like 20 25 kind, but actually the strength of this elective is 43 or 44 like that. Your attendance are always given in the their kept in record. Okay, so tell your friends also like to join the classes, do the classes, give their attendances. Okay, otherwise it may be troubling them later. So for all classes I'm telling, not for me only, because the attendance are being recorded for all the students. Inform your friends about this because your sessional etc. These are also going to be included. Your attendance etc. is also going to be included from your these sessionals for your sessionals. Okay, so till now only 8. Last class we were talking about the dampness. And I'll do one thing. Wait. We were in the last class, what we were doing, we were doing the, where we have ended was the effect of dampness. These was what were the for effects, ill effects of the entry of dampness. This we were talking about that. We have done these things. So the effects of dampness can also be these things, like they can damage your floor coverings. Dampness promotes and accelerates growth of termites, obviously. Okay, so dampness breeds germs. When you have damp, you already know, you have seen in your maybe in your nearby areas, or in your somewhere you have seen, I think somewhere or the other you might have seen this dampness effect of this dampness, like when some of the materials of your wall, or outside wall outer layer comes out due to this dampness effect, what happens, the you have seen, I guess, right? Let me ask you, how many of you have seen this? If I do manage pen, um have you seen dampness in anywhere? Damp CPU or structure, and I'm not able to do this. Okay, whatever. Okay, so these are the effects, right? We have already discussed these effects: moisture causing rusting and corrosion of metal fittings. Okay, flooring gets loosened due to reduction in the adhesion. These were some of the effects. Okay, electrical fittings will also be deteriorating due to this dampness effect. Now, what are the methods of your damp proofing? You have to, for to avoid this dampness in your structural member, what you have to do, you have to do this damp proofing. So how you can do that? There are different methods for that. And what is that? These are the methods for your damp proofing, which is use of damp proofing course. You can either use a damp proofing course, okay, which is a membrane damp proofing. Then we have internal damp proofing. It can be surface treatment. You can treat your dampness by this surface treatment, cavity wall construction by gunniting or by pressure gunniting. So what is your membrane damp proofing, which is when we use a damp proofing course, okay? So membrane damp proofing is actually what? In this method, you will have to use some water repellent membrane between the damp surface and the part of the building, okay, where it is dampness you have observed, okay. So you have to use this membrane in between them. So this DPC may be bitumen, it can be bitumen, it can be mastic asphalt, it can be bituminous melts, plastic melts, or metal sheets, cement concrete. Also, what happens? DPC may be provided horizontally or vertically in the floors, walls, etc. Wherever you want. Like suppose if you have a damp in your vertical wall, outside outer wall, what you will do? You will place your DPC there. And if you have on the floors, on the, that means ground floors. If I talk from the, if you, I said you in the previous class, like if you have a very weak plinth, or your plinth is not constructed properly, made properly, what happens, your, if your water level, underground water level increases, it may, sometimes what happens, it may damp your floors, okay, which is just above your plinth level. So In that case, you can also put a horizontal dpcs you can use. Okay, so these are the following general principles which should be applied while we are providing dpc. Okay, so dpc is what? Dpc should cover full thickness of the wall. Then we have the mortar bed, which is mortar bed supporting dpc should be leveled. Okay, it should not be higher somewhere, it should not be lower somewhere, but it should be leveled when we are using, because otherwise it will do the structure will not be what to say, it will be upper on the one side and it will be lower on the one side, so it should be level. Obviously you will not want that in your floors or in your walls. Okay, so it should be leveled properly and even, and should be free from projection so the dpc is not damaged. Okay, at junctions and corners of walls, the horizontal dpc on the floor should be laid continuously. When you have in your junctions, okay, when you have a junction of wall or beam column, okay, you have junction of the wall and the corner, that means corner walls. If there is dampness, you see some dampness there, you should give horizontally on the floor, should be laid continuously. You should use your dpc horizontally and continuously, okay, on the junctions of the floors. Then we have also in the walls also it should be continuous when you are using for the vertical walls. When a horizontal DPC is continued to vertical face, a cement concrete fillet of 7.5 centimeter radius should be provided at junction. Okay, so when you are, suppose horizontally you are placing, but also you have what you are continuing it to vertical, that means your dam proofing is big enough so that horizontally also you're placing, and then it is continuing towards the vertical side also, your wall also you are giving in the junction. So in that case we have to use some cement fillet on of 7.5, because on the junction there will be gap otherwise, right? So we are going to use this when we are using both vertically and horizontally our dpc. DPC should be next point you have to apply is what? DPC should be kept exposed on wall surface, otherwise it may get damaged during finishing. Okay, it should be exposed on wall surface. Then we have, next is your internal dam proofing. This consists of adding certain waterproofing compounds of material to the concrete mix. This is internal dam proofing. That one was external when we use some membrane after the dampness. But this is where you have to, internally you have to give the damping. That is when you're mixing the concrete. When you are mixing this concrete, right, at the time of mixing only what you do, you add this dpcs, that is the waterproofing material you're going to mix with it, so that it becomes impermeable. This waterproofing compound may be reformed. See, because when you're using cement, okay, when you're using your cement for your construction purpose, cement concrete mix, there are some voids, maybe there's some it may be not voids, but if suppose you have compacted it properly also, there might be some kind of some very minute what to say, voids, which is, or you can say it is permeable to water, and therefore when it rains or some underground, due to underground water or extra, when it rains or etc, then what happens, your water will, since this is permeable now, that is water can pass through this concrete, therefore obviously that will produce your damp, that will cause your dampness in your this member. Okay, so what we do in this internal damp proofing, we before mixing, before using this concrete in the concrete mix itself, we use the this damp proofing material. Okay, so that it becomes impervious. Your this concrete will become impervious and your water cannot enter inside your concrete, and therefore if it doesn't enter, what will happen, there will be no dampness in your structure due to this water. If it is unable to enter only, then how it can affect your member. Okay, so this is internal damp proofing. So it can be in three forms. This internal damp proofing can be of three forms, which is compounds made from chalk, chalk, fullers, earth, which may fill the voids of concrete under the mechanical action principle. These can be used. Then we have the next one, compounds like alkaline silicates, aluminium sulfate, calcium chlorides, etc., which reacts chemically with concrete to produce waterproofing cores. Okay, this will act chemically, but here in this form, in this first form, where the compounds of chalk, talk, fullers, earth, etc. are mixed, what happened? They are what they are doing? They are filling the voids. These voids which I was talking about, these voids are filled by these materials, chalk, talk, fullers, etc., so that it becomes impermeable. Okay, there's some to 50-60% or 70%. So another one is your this one, which will react chemically with your waterproofing and make it impermeable. Your this concrete mix, it will make impermeable by using this silicate, aluminium sulfate, calcium chloride, etc. Another one form, another this is the third form, which is compounds work on water repulsion principle, like soap, petroleum, oily fatty acid compounds such as stearates of calcium, sodium, ammonia, etc. When they are mixed with concrete, become water propellant. Okay, these are some of the water propellant compounds, like seawater repulsion, like the soap, petroleum, oily fatty acids. What are they? When they are mixed with your concrete, what will happen? They are those kind of materials which will not soak the water. Right, you know what is oily fatty and this oils fatty and this soap, etc. They repels the water, right? They will not absorb the water, but they repel. That means when you mix it with this concrete, these water repulsion, with the help of this water repulsion principle, which these materials which show water repulsion principles, when you use in this concrete, what will happen? When you use in this concrete, when from suppose in the outer surface wall you have used, now what happens when it rains, etc., your this is not going to this material is not going to let the rainwater or any kind of waters or moisture enter in your inside your this concrete. Okay, because they are water repulsion, they are repelling water, they don't absorb water. And this layers, this soap, petroleum, oily fatties, which when they're used with the concrete mix, what happens? They are on the outer surface of this concrete wall. Suppose this is a wall, and on the outer side you are having, these are the outer sides. When you have on the outer sides, you have your this water repulsion materials compounds. When we use, what will happen? Your water cannot enter inside the concrete, and therefore obviously it will not produce any dampness. Next is commercially available compounds like Pablo, Permos, silica, etc. So there are some nowadays, there are some commercially available materials also, which are applied on the okay, which are applied on the concrete mix. They can be repulsive in principle, they can be of repulsive principle, or they can be chemical also can be mixed with them, so that they doesn't allow the water to get absorbed in the concrete. Okay, these are commercially available nowadays. So next one is what? Surface treatment. Now, next one is surface treatment. We can treat our dampness on the surface also, outer layer. So, what is that? You have the surface treatment will consist of applications of layer of water repellent substance. Okay, earlier in that internal treatment, what we did, we had mixed with the concrete, we had mixed the water repellent compounds, we had mixed here. But here on the surface, when you already have the dampness, you have seen in your structure already. Okay, the in layers, or like some rough layers, it is coming out of your wall, uh, the paints, etc. So what is that? That is nothing but your dampness. So what happens on the surface, you can treat them by applying on the outer surface, you can apply this layer of water repellent substances on the surface, through which your moisture enters. Okay, so on the outer layer, what you're going to do, you're going to use this water repellent substances. Next is the use of water repellent metallic substance soaps such as calcium and aluminium ollets, and steroids are effective against rainwater penetration. So on the surface, when we're using, we can also use these repellent substance, or we can use these kind of chemicals like calcium, aluminum, oils, metallic soaps. These compounds are made up of chemicals, so these also you can apply on your the damaged portion, okay, or the dampness which is there present you have seen on the surface. You can apply these chemical compounds also. Pointing and plastering of the exposed surface must be done carefully using waterproofing agent like sodium or potassium silicates, aluminum or zinc sulfates, barium hydroxide, and magnesium sulfate. Okay, on the surface treatment, when we're talking about surface treatment, we also should take care of our plastering, okay, of the exposed surfaces, um, so that when you are doing the plastering and the painting, this is not pointing, okay, this is painting and plastering. When you're doing at that time only, you can do what, you can take care of this, uh, you can use waterproofing agents on them and your plastering and the painting, okay, such as those your paints or plasterings may should you can use their the silicates, aluminum or zinc sulfate. These chemicals, you these compounds you can use on your plastering, so that on the surface itself they are there, and they does not allow your water to penetrate inside your surface. Then we have surface treatment is successful when moisture is superficial, okay, when it is that means when you have it is not yet the dampness is not yet done, but it can happen, okay. What is this? Okay, so we have what this surface treatment is successful and moisture is superficial. That means when it is visible to us, not internally, but when it is externally, it is visible that water is coming in, hitting the surface, or the water is remains here. Suppose in your chazas, etc. This is a window, and this is a chaza, and your chaza is not properly constructed, so water is stored here. It remains stored here after the rain, and then this joint is getting damped, okay, and as a result of which the strength is decreased here, okay. In that case, we are looking that the water is visible here, so and in these places we can use this surface treatment here, okay. If you don't want to break this and again you don't want to construct, then you can do the surface treatment here. Next is your cavity wall construction. How you can do in this method of dam prevention, in which main wall of building is shielded by an outer skin wall, leaving a cavity between the two. Okay, so you know this is another method of your dam proofing. That is when you have an external wall where you can obviously you know that your suppose this is your wall. I'm sorry, it was like this. Okay, wait. Suppose suppose this is your wall, okay, and here you are having your building. You are having a building here. Okay, this is the wall. This is the wall of the building. Okay, this got okay. This is your building. Suppose this is the main wall of your building. Okay, now these main wall can be protected by giving an outer skin, you can say, of the wall. There is a this one, this you can give a outer skin wall, because such that there is a cavity, this is a cavity between the main wall of the building and the this outer skin wall, so that when your rain comes also, when your rain or any kind of waters attack on your wall, they are going to attack on your this outer layer of the skin wall. Okay, and this is, you can see here, this is the gap. Here you have this cavity. Obviously when your water is attacking here on this wall, they are not going to, this is your cavity. So when your water is coming and hitting in your this outer skin wall, they are going to damp. If they damp also, they are going to damp this wall, not your main wall, because there is a cavity. Your water cannot reach your this wall. Okay, so on all the four sides of the your building wall, you can use this outer skin wall. Okay, very small cavity. Okay, this is a very small cavity between them. So this is cavity wall construction. With the help of these method also, you can prevent your dampness in your structure. Now another method is your gunniting. Okay, so what is that? This consists of depositing layer of rich cement mortar by pressure to the exposed surface of wall or pipes. Gunniting means what? That means what you do is you give cement concrete inside. Okay, like suppose I'm telling, gunniting means, suppose this is your some structure. Here you are having some dampness, suppose. Okay, this is your dampness, suppose, due to which your some layer of your this wall is coming out. Then what we do, gunniting means you insert here the cement mortar. Gunniting means with the pressure, you, like, just imagine like a gun. What does the gun do? It is when you with the help of gun, when you hit, it comes out, your bullet comes out in that way. With the help of this, your cement mortar is going to, you are going to push, or you're going to push the cement concrete inside your this gap, which is due to the dampness, your layer has come out. So you're going to use a machine, a kind of machine which is a gun kind of machine, where you are have inside it the mortar. And so when you use that, start the machine, it is going to throw the mortar, or you can say it will push and hit the machine. It will fill these gap with the help of those mortars which is coming out through this machine at a very force, at a very high force. Okay, so that, like in the case of gun, you see. So that this is, it can also be done in this way. Your damp proofing can also be done with the help of this gunniting. Okay, in walls or pipes. Cement mortar is 1:3 cements and mix. When we are using with the help of gunniting, mortar is shot on clean surface with cement gun under 2 to 3 kg per centimeter square pressure. See here, the pressure is this much used, and when you shot that, when you start shot now, what happens? The mortar comes out of the machine and it is hitting the uh, the damped portion, so that it can set there, and then you cannot see the dampness in the structure. Curing of mortar is done for 10 days, and when you use that cement mortar, what happens? You will cure that for 10 days, continuous 10 days, so that it gains its strength. Okay, the ultimate strength of it. Now another one is pressure grouting. Grouting and gunniting is almost same kind. Okay, in this method, cement grout is filled in cracks, voids in the structure of building by pressure. Same thing. Okay, so foundation of buildings are subjected to grouting. Okay, to make water penetration resistant. Okay, so gunniting was like this shooting. Okay, like it is the mortar is shot in those areas, but in your here this is grouting. Grouting means you're injecting. When you inject this cement, it is called as grouting. Okay, same thing like in the kind, in case of gunniting, what we were doing, we are shooting, right? Shooting the cement, but in grouting, same thing, only it is injecting. We're injecting the cement concrete inside the void. Suppose there is some void or cracks. Okay, due to this dampness, what we do? We do this grouting. We are injecting the material, that is a concrete, to change the physical characteristic of your that member. Okay, so foundation of building are subjected to grouting to make water penetration resistant. You can use this grouting in your foundation to because sometimes you can see there are cracks in a foundation. If you want, you can just check, and then you can use this grouting, that is injecting, that means not a small but a at a large scale. Okay, this method is effective to control entry of groundwater through foundations. Okay, so these are your methods of your grouting. Okay, now I'll show you. Now I think I'll show you a video on the construction joints. Next, this was your dampness. This was your dampness, the methods of dampness, what is dampness, effects of dampness we have talked about, we have discussed. Now we'll be uh, talking about joints, water joints. So for that, I have no notes to show you, but I'll show you a video where you can see what are your joints. Okay, let me. Oh, I forgot to unmute myself. Okay, so when we are constructing any dams or any kind of bridge, okay, so we are constructing any kind of bridge, etc. So we will need some kind of joints there. So those are known as your construction joints. Okay, except when we don't have, we use in some small jobs, we don't need these joints in small constructions, but in large constructions like dams, bridges, etc., we use this kind of joints. Okay, so there are different types of joints. You need to know. So go through this video and just check out whether it is okay with you or not. So these are the types of joints. I'll just start the video. Just check. Especially in the huge projects when it is not possible to provide or execute the project in one go. It is very difficult. So that's why we provide construction giants. So giants are also required for functional consideration of the structure. So here are various kinds of construction giants that we are going to discuss about it. So broadly speaking, we have three different types of construction giants. First is construction giants. Second one is expansion giants. Third one is contraction giants. So depending upon the situation and the type of the construction, we provide different types of giants. First, we are going to discuss about the different types of construction giants that we provide during construction. So actually, these type of construction giants are provided where there is a break in construction program. And also, location of construction giants should be that it also interferes the minimum with the functional characteristics of the structure. Also, these construction joints are also provided in those places where there is multiple placing of concrete takes place. In huge projects, sometimes concrete is poured in more than one steps. So disruption in man hours creates such kind of problem that we cannot pour concrete in single go. So in order to remove this kind of problem, we actually provide construction giant.
Second kind of reason is sometimes due to disruption in our project or due to any kind of holidays or any unexpected happening or incident. We have to stop the work at some point and then we have to start again the project by providing construction times. Third kind of reason is sometimes it happens that the material is not available in the market, and also there might be a chance that some machinery is not available. So in order to accommodate all these kind of things, we have to provide these construction giants in order to carry out our project. So the second kind of giant is expansion giants. So they come our project. So the second kind of giant.
Understood the first construction joint? Okay, I think my I'll share you the 5 minutes are left. I'll share you the link for attendance. Just go and give your attendance. Let me first of all let me share my link with you all. Do you have with you the previous link I shared with you for your attendance? If you have, then you can directly go to that link and you can give the attendance. Use that link.
No, no, ma'am, we don't have.
You don't have? Okay, I'm sending it. But for other classes, like whenever we do this construction practice class, you go to this link only and give your attendance after the class. When I say you know that go and give your attendance, you just use that link only. Okay. So save that link and keep. I will share with you now in your chat box. I've shared the link. Go to the link and just save this link somewhere. Okay, and use this link only whenever you give your attendance. D3. Okay. So I hope you understood this first joint, which is your construction joint, where why we use and where we use this construction joints in huge structures. When you have what you have when in the huge structures, obviously when you are constructing some huge structures, what happens? You in a single day you cannot make that. Okay, and sometimes what happens? Because you are mixing so much quantity of concrete, but there may be some hindrances while you are constructing, but you have already okay, sorry. When you have this kind of huge construction works, what happens? Sometimes there may be due to weather, you may have to stop your construction there. Due to some bad weather, you may have to stop the construction there. And then what happens? Next day again, you have to come and you have to do the same member. You have to make a huge member. So in that case, sometimes what happens? We can give joints there. You have to give joints on the structures when it is in such a way that you cannot continue with the concreting. Okay, so in that case you can join those, you can use this construction joints. Okay, sometimes what happens, there are some problems in the project and then you have to leave that work for months or years, and then what happens, you have to give some join there, but again you have to restart the construction work. In that case, what you do in that case, again we are continuing with the structure, but now after a year or a month, if you have to start, we are again starting the same thing, same member we are constructing, but now using a joint, giving a joint, again we are continuing that project. So that is your construction joint. Okay. And next one is your expansion joints.
Is expansion joints. So the concrete sometimes is subjected to volume change due to many reasons. For example, due to heavy loads or due to change in temperature, it happens that sometimes concrete may change its volume. And due to change in its volume, it actually puts pressure. So in order to accommodate that pressure, we have to provide these expansion joints. So these joints are usually provided